My name is Jeff Fontas. Welcome to LinkedIn. I'm a partner engineer here. And tonight I'm going to talk about OAuth2 best practices in native apps. I kind of adjusted my title a little bit, but we'll still talk about desktop apps, especially apps built with Electron and Node WebKit, and what kind of changes when you're dealing with an app that's living physically on a device. But before we talk about that, first let me say welcome to LinkedIn. The SFNode Meetup was one of the first tech meetups that I went to when I first arrived in the Bay Area in 2016. So it's like definitely a personal connection that I have that I'm really excited about, that Node is now at LinkedIn, and LinkedIn is furthering its support for the JavaScript community by hosting it. So I'm very excited about that. And I will say that I actually have gone to a number of the other Node events, Node School in particular, and those are super awesome ways to meet people in the community as well. So definitely encourage you to do that. And before I get to the talk, I did want to talk a little bit about partner engineering, because it's a department that before I came to LinkedIn, I didn't know it even existed. And we're hiring, so I wanted to talk about why it's so cool to work on this team. So the first thing is that the world is no longer a place where you can just build an application on your own. In most cases, you need to be integrated with other platforms or products. And we're the operational team at LinkedIn that enables partner integrations here. So what that means is we manage the API gateway that exposes our services for developer applications to consume. We write the technical documentation for all of our APIs. We also troubleshoot failing requests. So if a partner has a failing request that they're trying to make, we actually will look at logging and decipher like what's going on within our own infrastructure so that we can work with the engineering teams to fix those issues. And then finally, we think holistically about the design and scale of our platform and how we can reach more of our members and deliver more valuable experiences to them. So not only that, but we work across engineering and product teams internally and externally. So we'll work with CEOs and CTOs of startups who are integrating with us. We'll also work with VPs of product and engineering leads at big organizations who are building integrations with us. And then we work internally with incredible product and engineering talent here at LinkedIn. So I actually had some things on the slide. So we enable integrations. We have amazing coworkers and partners. The other thing is this is all under the umbrella of a values-driven culture where we put members first. So that's a really awesome place to be. And with that said, if you're interested, I'll be here after and happy to talk to anyone who would like to join this team. I would say the best types or the best backgrounds are people who are senior engineers who are looking for something that's more communications focused than what they're currently doing. But happy to talk to anyone who's interested. We also have other roles open as well. So we have Clark, who may be here after, who can tell you about other roles that we have. All right. So with that said, let's talk about the agenda. First, I'm going to say a few words about OAuth2, just like what it is, just in case anyone may not know. And then I'll talk about native apps and what makes them different. And then we'll talk about best practices, and I have a demo implementing those best practices. So how many here have used OAuth2 before? Cool, like 50%, that's good. All right, let's get started. So at a high level, what is OAuth2? OAuth2 is a framework for enabling users to access resources that they own through some applications. So if we have a user and they want to access their profile data on LinkedIn through some application, OAuth is the process that enables them to give consent to access that information for the third party. So there's a couple pieces that are important for this talk in particular to understand, because they change a little bit when you're dealing with native applications. The first is getting consent. So in order for these apps for any app to access your data, like your LinkedIn data or whatever it is, you need to have a means to grant consent. And the most common means is through your browser. You'll have a consent dialog like this. In this case, I am being asked to grant access to Jeff's test app to use my name, photo, headline, and current positions. So what this means too is behind the scenes that this is on LinkedIn, and LinkedIn has to have some infrastructure that determines, okay, Jeff's test app exists and it's allowed to ask for these permissions before we can even get to this consent dialog. So there's a lot of different pieces that go into this that are being that are working behind the scenes when you are presented this dialog. After I allow access, what's happening is my browser is going to be redirected, right? So let's talk a little bit more about what that redirect actually is. So I hit allow, the browser's redirected. LinkedIn generates an auth code or an authorization code that basically says, I've consented to this third-party application giving me access to my profile data. And then what will happen is the redirect will then force the user's browser to make a request to some infrastructure that Jeff's test app, in this case, owns, so it can receive the OAuth, or so it can receive the auth code. And that auth code will be sent in a query parameter. All right, so what happens once that Jeff's test app receives the auth code is it then posts that auth code back to LinkedIn in a form post body. And it sends it along with a client ID and a client secret. And that client ID and client secret basically function as a username and password for that application. And at its simplest, what's happening is the user grants the authorization, and then the application is taking that grant and saying, I am who I say I am, and this person has given me authorization, so give me the access token that I need to then make calls on their behalf. So the one thing that's important to note too about secrets is it's really important that they are kept secret. Otherwise, a rogue actor, if they had your secret, they could intercept, and they had the means to intercept and receive the auth codes, could generate tokens that your application is not aware of. So it's really important that those are kept secret. After sending the auth code and credentials, the third-party app will receive an access token. And then to use the access to actually make requests, you send that access token in every request. And basically, you send it an authorization header. In this case, we're requesting the profile data that we consented to allow in the first step. All right. So now that we talked about OAuth, let's talk briefly about native apps. And what are they? Put simply, they're basically any application that doesn't run within the system browser. So they, and we can go a little bit further and say, so like the mobile apps, iOS apps, or iOS apps and Android apps, desktop apps, like apps built with Electron or Node WebKit. What makes them different is that they're physically on the device. So because they're physically on the device, they actually can't keep secrets secret. So there are other ways, and we'll talk about in best practices, actually how we deal with not being able to keep secrets in native apps because they're physically on devices. But that's just one consideration, is that because the software is physically on the device, you can't protect the secret. The second is that they use embedded browsers. So if you're using the embedded browser for the OAuth flow, that could be good, but the differences with embedded browsers is they're updated less frequently. So if you are using Electron and there's some security vulnerability in Chromium, Chromium is not going to get updated for a couple weeks for Electron, and then it takes even longer for that app to get out to the user, right? So you have this window of time where there's a lot more risk. So a lot of places like Google is a good example. Like they don't even allow you to go through the OAuth flow in an embedded browser because of security risks. All right, so let's talk about some best practices. Now I know kind of like what the problems are. So the first is like kind of what I was just alluding to, use the system browser. So there's a couple of reasons for this. The first is usability. Especially in desktop apps, users will pretty much always have active sessions going. Like if I'm on my desktop, I'll have an active session going with LinkedIn, right? So what that means is you don't have to have the user log in again. So it's easier for them to grant their consent if you use the system browser rather than an embedded browser that has its own cookie store and doesn't have an active session. And then the second piece is obviously security. We just talked about this. Like the system browser is frequently the most up-to-date browser on the system. So that's another consideration. All right, so that's all good and well. Like, if you use the system browser, how do you actually, you've basically lost context in your application, right? You've sent the user somewhere else. So how do you know when they've gone through the process, given consent, and the auth code has been generated so that you can then use it to get the access token? There's a couple different ways to do this. My slide's already given it away, but the first is using a custom protocol handler. And this is actually better for mobile apps because like the infrastructure is already built, right? So a lot of mobile apps, it may not look like the example we have up there, but mobile apps will give you the framework to use a custom protocol handler to receive the authorization code. And if you're using an SDK for OAuth, you don't even really usually have to be concerned about this, so long as that the SDK opens the system browser to perform the OAuth flow. The second option is, or actually before we go on to the second option, the other thing that's like important to consider is if you want to use a custom protocol handler, this is actually really hard. It's not really hard, but it's kind of a pain on desktop. Because if you're dealing with OS X, Linux, and Windows clients, there's 3 different ways for you to actually define a custom protocol handler. And that's kind of annoying. So if you're on desktop, the better thing to do is just listen locally, like open up a port and listen for HTTP requests locally. And then you can actually receive the auth code that way. All right, so the third best practice is, it's called proof key for code exchange, or PKCE. And this is an alternative to secrets. And the way it works is, it's a randomly you have clients randomly generate a code when you before you send them to the consent screen, and then you use that same code once you've received the authorization code and send that along with the authorization code when you get the access token. So this is basically a way of verifying that the same person consented that's also sending the auth code. So the other thing to consider is because there's no secrets, there's also this thing called refresh tokens, which your access tokens have a limited duration of time that they live. And refresh tokens allow you to mint new access tokens without going through the consent dialog again. So because there's no secrets, the OAuth2 like RFC spec doesn't allow you to use refresh tokens without secrets. All right, so I have a demo that kind of implements these best practices. I have some lessons learned about the demo, so I'll talk about them after, but I'll just describe it now. So we have Jeff's test app. It's a native desktop app built with Qt and PyQt. And what it's going to do is it's going to open the system browser. It has a button that says, "Who am I?" And before it can determine who I am, it's going to open the system browser so I can consent to giving my access to LinkedIn info. That system browser is going to redirect with an auth code to a Node server that's spawned from the process and is just listening locally for that auth code. And then it's going to be, once it receives the auth code, Node will actually make the request out to exchange that auth code for an access token. And then it will send that back to the test app. All right. So let's talk a little bit. Hopefully you guys can see this. Yeah, cool. So this is like very kind of boilerplate request handler, but basically all we're doing is we're listening. We're going to part for HTTP requests on port 123. We're going to parse the query string that shows up in the requests, and if we receive an auth code, we're going to then build a request to an endpoint, the OAuth access to endpoint for LinkedIn. We're going to send the auth code along with our client ID, the generated code that was generated when we send the user to the system browser to that consent screen. And then we're going to just write the access token that we receive back out to standard output. All right, so before we do lessons learned, all right, it's not going to do anything. All right, so I'm not a great UI developer, so sorry. But if you can't read it, this button says, "Who am I?" And if I click it, where did my screen go? Hold on, let me. All right, so what will happen is I click "Who am I?" I'm asked for consent. It's the same thing we had before. I hit allow. My node process that's been listening locally is receive the auth code, exchange it for an auth token, and then if I go back, we can see that I am Jeff from LinkedIn. So that's the whole deal. Let me go back to our presentation. I'll show you some lessons learned about this approach. All right, so the first lesson learned is don't spawn a child process. This is kind of just like a lot of extra work and overhead that you really don't need. So in that same vein, use whatever tools are at your disposal in your native application. So if you're using Electron or Node WebKit, use Node within Node WebKit and just listen locally there. If you're building a Java app, listen with Java. In this case, I should have listened with Python. The other thing is once you spawn a child process, you have to do all this inter-process communication management. That's just like a lot of work. You have to handle error states and what if they don't give you consent and all that sort of stuff. So it's much easier to do that within the context of your native app rather than having to have some other third thing that you have to worry about. If you want any further reading on this, there's RFC 8252. It defines OAuth2 for native apps. And proof key for code exchange is RFC 7636. And that's it. So if you want, I'll do questions.
Yes.
All right. Oh, do you guys like it here?
Have you guys tried or had issues or looked at, had experience or with granular control of OAuth permissions? Not just all in one, but allowing people to grab maybe just the emails or contacts and not everything else.
Sure. So I can speak to that. So a lot of that is something that the platform has to enable in the form of granular permissions. So one thing I didn't mention is scopes, and scopes are kind of like what you see in the dialogue as you say, okay, like this application wants to have access to your profile data, it wants to have access to some other things that you may have on this service, right? And in the back-end configuration system, that's really where all of those things live. So it's really up to the platform to enable those things for third-party developers. So I don't know if that answers your question. Like there is a way to request multiple scopes. And so long as those permissions exist as a third-party developer, if you have access to those scopes, then you can limit the access to just what you need to use. Yep.
Any other question? Hi. You were talking about one of the other best practices, which is around not storing secrets on the client side. So when I sign up for a new app with LinkedIn, I'm given an ID secret that I need to use when I'm making a OAuth request.
Yep.
So if I'm creating a client-side app, I'm making an Electron app or something like that. I think maybe I just missed it when you talked about it first. But what's best practice then for dealing with using those when I'm using the client-side SDK to make a request back?
Sure. So if you're building a mobile app, it doesn't require your secret. So we have a mobile SDK that would enable you to not use the secret at all. And it basically is that PKCE technique, which is like you generate a random string in place of the secret. And you use that when you make your initial authorization consent request, and then when you exchange the auth code for the access token. But it's up to the platform to implement that. So one thing that I didn't talk about that I was going to talk about was what you can do is if you have the bandwidth, the development and engineering bandwidth, you can actually have a service that you redirect to that lives in the cloud and receives those auth codes and then sends them down to the client. And then you can keep refresh tokens on that service rather than, you can't send the refresh token down to the client because they need the secret to be able to exchange it to get a new access token, right? That adds another layer. You have to do user management to make sure that you know whose access token belongs to who, basically. So I don't know if that is helpful, but yeah.
This was sort of like a follow-up on what he just asked and you just explained. So since we are not dealing with a refresh token, and as you said, access tokens usually expire. And so once you have that initial access token within the system browser cookies, I'm assuming, and you want to refresh it in like 5 minutes, without a refresh token of sorts that you're sending and receiving, you would potentially have to keep listening for some sort of event. I just wanted to know, like, there's a gap in between that.
Sure. So typically what happens is if your auth token or your access token expires, you'll get some sort of HTTP response code from the service that you're trying to request that's like 403 or 401 unauthorized or whatever. And you can rely on that to request new authorization codes that you can then use to get access tokens. A lot of times platforms will store the consent and say, you've already consented to this application. So like you saw, what I was doing is I had already consented to using my test app, and I had to blow that away for us to actually see the dialogue. And with that stored already, you automatically get the authorization code, right? Because I've already given my consent to it. So you don't actually have to have the user go through the whole process again. But as the access tokens expire, you do have to generate them again and have that handshake with whatever that resource is that you're trying to reach out to.
All right.
Cool.
Thank you very much.
Thank you.